there yet 2 times. Dangerous. 3, we say are we there yet 3 times. Right? But obviously what? Every number that goes up, I have to add an extra line, right? And I have to copy and paste this over and over and over. That doesn't sound good, right? You think, but we don't have to do that. All right, so that's approach 1. See if we make it a little bit more succinct. All right, approach 2, if count is greater than or equal to 1, are we there yet? If count is greater than or equal to 2, are we there yet? If count is greater than or equal to 3, are we there yet? All right, so on and so forth. Easier to copy and paste, agreed? All right, what's the only thing that's changing now?
Your increment.
Right, my incremented number, right? Because if the count's 1, it'll output it 1 time. If the count is 4, it'll output it here, and here, and here, and here. Make sense? Still not exactly what we want to do. All right, let's try a third approach. Right, if count is greater than or equal to 1, we're going to output it, and then we're going to decrement the count. All right, and then I can do another if statement that does the same thing, and another if statement that does the same thing. Right, so I could copy and paste this code 1,000,000 times, and it would work for numbers up to 1,000,000. Right, but it wouldn't handle 1,000,001 or 1,000,002. Does that make sense? Every time the count is 3, right? 3 is bigger than 1, so we say, are we there yet? And 3 becomes what? 2. 2 is bigger than 1, so we say, are we there yet? And 2 becomes 1. Imagine there was another one of these, 1's equal to 1, so we say, are we there yet? And the count becomes 0. And then the next if statement, 0 is not bigger than 1, so we'll go to the next one and we'll check that one, it's not bigger than 1, and so on. Make sense? Right, and this is how we do looping in C++. Basically, we do this, but we just don't do it with an if statement. But that's the concept. We're going to do something, we're going to change a value that will eventually make that statement become false. And we're going to keep doing that until the statement is false. All right, so let's see what that looks like. So this is what it'll look like. All I did was I replaced the if statement with the word while. Right, and you read this as, right, while the count is greater than or equal to 1, we're going to loop. While the count is greater than or equal to 1, we're going to loop. So we're going to say, are we there yet? And then we're going to decrement the count, and then we're going to go back and do it all over again. So you're going to be stuck in this loop, right? And you'll be stuck in that loop until when?
It's less than 1.
Until it's less than 1, right? No, equal is fine,
still
right?
do it.
It's got the equal. It'll do that loop, right? So the loop loops while the condition is true, right? While the condition is true, we loop. Okay, when we get to the end of the loop, we check the condition again to see if it's true or false. If it's true, we rerun the code again. If it's false, we skip over the loop and continue on with our code. Make sense? All right. So that's what loops do. They allow us to just repeat a statement or usually multiple statements, right? Statements that you want to run over and over and over again in succession. Right? Statements that you want to run over and over again in succession. We're going to do it again, loop again, loop again. All right, we think of our game, right? The games are a loop. We play the first game, we get to the end. If they want to play again, we go to the top, and they play the second game. Ask them again, go to the top, play the third game. So we get a loop our code. The loop body is the code that's repeated, so that's just a key word. The loop body is the code that is repeated. All right, we put it in curly braces. Right, so going back to our example, are we there yet? And count minus minus. Right, that's my loop body. That's the code that will repeat while the Boolean expression is true. And when we check the Boolean expression and it's false, right, then we skip over the loop body and we continue with our code. All right, so that's our loop body. Right, going back to our highway example that we had with our branching statements, right? So you're driving along, right, in your code, right? You hit a detour. You only take the detour if the Boolean expression is what?
True.
True. You only take the detour if the Boolean expression is true. If it's true, we're going to go in, we're going to run our first loop, and then basically here, which is the detour again, you have to decide, is the Boolean expression still true? If it is, right, we get stuck in our hamster wheel, and we just keep going around in circles. Eventually, though, we want that Boolean expression to be what? False, and that's when we exit and then continue on with our code. So we're going to loop our loop body, right, until the Boolean expression is false. That ends our loop and then continues on with our code. Make sense? Right? Each repetition of loops is called an iteration. Right, so I'm throwing more words at you, but an iteration is each repetition of a loop. And a lot of times we count the iterations of our loop. So sometimes we can say, we know it's going to loop 5 times, it's going to loop 10 times, right? 5 iterations.
Just because you want it to be false at some point.
You want it to be false. It has to become false at some point. Or you have an infinite number of iterations. Your program will just stay running for forever. I'm going to do that today. You'll see my CPU go all the way up. The CPU on top. You can also count how many times the loop is going to iterate. So that's what we're saying. All right. Let's look at this example. I have some integer that starts at 5. We're going to loop while the loopant is greater than 1. And every loop, we're going to decrement our integer. Okay, so the question is, how many times am I going to iterate? Anyone want to throw out a number? 4. I got a 4. Any other numbers? All right, I got a 4. Should we check it? No, we just assume that everything's right. All right, we learned that last time. Assume we always do things correct. Right? So let's look at this. I have my loop in. Right? It starts at what? 5. Okay? Once I start doing loops, I get out of my boxes. I know I've been in these variable boxes like all semester long, but now that the value is going to change a lot, I don't want to erase, right, over and over and over again. I'm going to kind of just bring them down. So you'll see that, right? And then I'm just going to count the iterations. Right? And so the way our code would work is, right, variable would be created. I see the while loop. There's a Boolean expression, so I need to evaluate that Boolean expression. Expression will become true or will become false. Agreed? Right? So we look at the value of loop int, which is 5. 5 bigger than 1?
Yes.
Yes. So I go into my loop, iteration 1, right? So I'm just going to do a mark for iteration 1. It's a very boring loop. The only thing that happens in my loop is what?
The decrement.
Loop int decrement, so it becomes 4. Agreed?
Yeah.
Okay. I hit the end of my loop. Where do I go?
Back to the top.
Back to the top, to the check. Right? I'm going to do my check. Right? Loop int's a different value now. It's 4. Is 4 bigger than 1?
Yes.
Yes. So we're iteration 2. Right? And then 4 becomes what?
3.
3. Into my loop body, so I go back to the check. Is 3 bigger than 1?
Yes.
Yes, so I do iteration 3. 3 becomes
2.
2 bigger than 1?
Yes.
Iteration 4. Decrement. It becomes 1. I go back to my check. Is 1 greater than 1?
No.
No. So I skip over the loop body, right? I don't decrement loop in again, right? I skip over the loop body and then I continue on with my code. Much like an if statement would skip over the body, right? And continue on with whatever. Right? And so you guys are smart because the answer is what? 4. 4, right? 4 iterations. Started at 5, it went bigger than 1. If I went bigger than or equal, then it would have been 5. Yeah. So we're going to talk about that. Well, I guess I'll talk about it now. So you go up or down. If you start at 0 and you go less than a number, right, then you loop that many number of times. Or if you start at 1 and you go less than or equal to a number, you also loop that many times. Right? So if I start at 1, just assuming that I'm incrementing by 1, right? You can increment by whatever, you can decrement by whatever. I'm just assuming we're incrementing by 1. If I go 1 and I go less than or equal to 100, right, I'm going to loop 100 times. If I go 0, less than 100, I'm also going to loop 100 times. Right? The same way, right? If I start at, right, a number, right, and I go greater than 0, that would work. Or if I start at a number and I say greater than or equal to 1, right, that'll also get me as many iterations. Okay. Where people get off is when they start at 0 and they go less than or equal to a number. Right, so if I start at 0 and I go less than or equal to 100, right, I'm counting up, I'm going to do 101 iterations.
Because it's counting 0.
Right, because it's counting 0 as 1, and then it's also counting 100 as 1 because we said equal.
It's like the inverse of that, that's right.
You want to make sure you do one or the other, but not combine them and do a messed up. Are we good with loops?
Yeah.
All right.
While loops.
Let's talk about while loops. I realize I should probably get Cloud9 started, so I'm going to do that in the background. Alright, so we have 3 loops that we're going to talk about today. A while loop, a do while loop, and a for loop. We'll talk about why we use all 3 of them. But let's start with the while loop, the one that we just saw. Right? So while loop is one of the loops we have. Right? Repeat code until a condition is met. Until a condition is false. Right? That's the big key, right? We're going to loop while it's true, meaning once the condition is false, right, our loop will end. Okay? Please know though, our loop doesn't end when that condition becomes false. The loop ends when we get to the end of the iteration, and then we go back and check. Okay, so don't be confused. It's not like it's going to continuously check every line of code to the condition change, right? No, it's going to run your whole loop, and it's going to go back to the top check, right? So every iteration it checks 1 time. At the end of the iteration, it checks to see if the Boolean expression is true or false.
So even on the false one, it's hitting the bottom, realizing it's false, and then moving on.
Yes. So always get to the end of the iteration first. You can technically do it without curly braces, but you would never write a while loop without the curly braces because, okay, let's think about this. You want to loop something, agreed? And you need to do something to change the Boolean expression to eventually be what?
False.
False, which is going to take at least 2 lines, right? 1 line to do something, 1 line to change the Boolean expression to be false. Right? So you always use curly, but technically you don't have to. That's just don't do that. All right, here's my example. I starts at 1. I'm going to loop while I is less than or equal to 10. I'm going to see out I, a space, and also then on the next line increment I. How many times am I going to iterate?
10 times.
10 times? Is that what we think? Did I just turn on the wrong line?
Oh wait, well, I is 1.
I is 1, I'm going less than or equal to 10.
9.
I have a 9, I have a 10. Right? We'll see which one's right.
Yeah.
It is 10.
I dissected this one.
All right, if you start at 1, you go less than or equal to the number, that's good. You're going to go that many numbers. All right, here's I. All right, I starts at what? 1. All right. I told you today's lecture is going to be very repetitive, right? So I'm going to repeat myself a lot. Is 1 less than or equal to 10? Yes. So what do? I loop, right? So I see out I. Right, the value of I is what? 1. And then I put a space, which I can't show. Right? And then what happens to I? Increment, it becomes 2. Okay? The end of the loop body, where do I go?
To the while.
To the while check, right? Is 2 less than or equal to 10?
Yeah.
Yeah, so I go into my loop, I see out 2, right? Remember I see out in the space before, so there's a little bit of space. 2 becomes what?
3.
3. Right, go back to the Boolean expression check. 3 less than or equal to 10?
Yes.
Yeah, so I'll put a what? A 3, right? One nice thing about loops is like, for basic ones, once you see the pattern, you kind of know what's going on, right? What's going to happen? This becomes a 4. 4 is less than or equal to 10. We get a 4, right? And it keeps going down until 9. 9 is less than 10, right? 9 becomes 10, right? So I'm here. 9 became 10. I go back. Is 10 less than or equal to 10?
Yeah.
Yes. So I'll put a 10 and a space. 10 becomes what? 11. I go back to the check. Is 11 less than or equal to 10? No, right? False. So then I break out of the loop, right? The loop ends, I skip all this, and I continue on.
So,
Right, my variable's now 11. I was going to make a comment about that. Give me a second.
that's just what I was going to check.
So it should make sense that the variable is going to have to at least be 11 in order for your loop to end. Right? Because when it's 10 or smaller, then it's going to be less than or equal to 10. Agreed? So I has to become at least 11 for your loop to end. Right? It could do that on 3 iterations. It could do it on 1,000,000 iterations. But at some point, I has to become 11 or more in order for the loop to end. Does that make sense? All right. Otherwise, you're gonna be stuck for forever. Right? Gotta get thinking. That's it.
Lost server.
That's a while loop.
Oh my gosh,
Can you
the
do,
CPU. Look at the CPU on this thing.
plus
Damn.
over 2. Use an operator with
You can do I plus
6%.
over 2.
Oh, wait, the program stopped. Hold on.
plus 1 divided by.
Right, I couldn't remember if you could do that.
There we go. It's on a break. Damn.
You can't use those with operators.
Right.
Okay.
Let's look at a while loop. Alright. And for our while loop, I'm going to go ahead
There it
and
goes.
I'm going to use the debugger so we can see line by line what's going on in the while loop. I won't do it for the other ones, but I'll do it for this one. Alright. I have a variable called countdown, and then I ask the user how many greetings they want, right? And they're going to tell me, right? As long as countdown is bigger than 0, we're going to output hello. We're going to output what iteration we're on. Notice iteration starts at 1, right? Then the countdown is going to go down, right? And the iteration is going to go up, right? Countdown has to become 0 or less in order for my loop to end. Does that make sense? Countdown has to become 0 or less in order for my loop to end. Right? And once I end, it's going to say that's all, and we'll be done. Alright, everyone see I have a breakpoint already set up here on line 22. That's where my program should stop. Alright, so I'm going to run it. And stop it because I want to turn on the debugger. So turn on the debugger, have a breakpoint, so now I can't run. Alright. I get all this fun stuff. Alright, let's just do 4 greetings. I'm gonna put this over here so we can see. So my program stopped on line 22. Right? But now in the debugger, I can now go line by line through my code. It tells me that countdown's value on the right, countdown's value is 4. That's the value I inputted, right? And what iteration am I on? 1 iteration. Okay. So, is 4 bigger than 0? Yeah, right? Aren't you glad it's the computer that makes these decisions for you? That's a really hard question. Right? Because it is, we're going to go inside the loop. Agreed?
Yes.
Right? So my program's going to output hello. It's going to output the iteration number. Right? Countdown's going to go down. So it was 4, now it's going to be 3. I'm asking really hard questions today, guys. We can do it. Right? 3. Iteration that was 1 becomes what?
2.
2. Right? And in fact, right, remember tracing is the idea of watching our variables change. Right? Countdown's down 3, iteration is down 2. 3 bigger than 0? Yes, right? So it goes in, it says hello, the iteration. Countdown goes down, 3 becomes 2. Iteration goes up, 2 becomes 3. Right? Notice at the end of the loop, it always goes back to the Boolean expression check. At the end of the loop, goes to the Boolean expression check and checks it. 2 greater than 0.
Look at the CPUs, 105%.
Yeah, so we go in, countdown becomes 1, iteration becomes 4.
Fresh.
1's still bigger than 0, so we hit say hello. Countdown goes down, iteration comes up. Right? Now though, countdown is 0. Is 0 bigger than 0? No. So I'm going to go in the loop. Say no. All right. And so I'm on line 22. What next line is going to run?
The iteration is going to go up, and the C down is going to go down.
Well, I'm already beyond that, right? I did that. I'm here now. Countdown is 0. 0 is not bigger than 0. So what line am I going to go to? That's 28. After, right? 28. So I'm going to hit F10 to go one more line. Notice we just be from line 22 to line 28. The Boolean expression is false, so we skip the body of the loop.
35,000.
All right, if we look at our output, all right, we got our iterations and then that. Make sense a little bit? All right, so that's a while loop, okay? Loops while the condition is what?
True.
True. And breaks when it's false. Yeah. You guys got it. Good. Let's talk about the do while. Right? Ooh. That's not so much more exciting. The do while. Okay.
Do this while this is true.
A little bit, not quite that. So do while is the second loop that we have available, right? Like a while loop, it loops until the condition is met. It loops while it's true and stops looping when it's false. So it's very similar to a while loop, which is why it's called do while. All right. The difference is that a do while loop always runs the code at least one time, right? So the do while says do, as in do the code, and then while that condition is true, do it again. The while loop says check at the beginning. If that Boolean expression is false, the while loop will never run. That make sense? It could not ever run, right? So a while loop might not ever run, because if that Boolean expression is false, right? So if I go back, right, and I can show you a quick example. If I go back here, right, I run my code again, no more debugging, just run it. Right, if I say I want 0 greetings, is it gonna say hello? No, right, because 0 is not bigger than 0, so it skips over the loop, right? So while loops are not guaranteed to run, ever, right? Because they could just say, no, it's false.
But that's safe sometimes when you're making a program with someone entering something. Let's say you're trying to retrieve money out of your bank. They're not going to give it to you if your funds aren't sufficient. It's not going to run that.
Right, so check, right? Where do you want to check first, right? Whereas if you're getting input from a user, you actually want to get the input, and then you want to check it. Right, so you want to get the input, check it. While it's not good, you want to do what? Get it again. Right, so that's where the do while comes in. So it looks like this, keyword do, curly braces, and then we get the while with the Boolean expression. The weird thing about the do while is that there's a semicolon at the end, right? Do, while, open close paren, semicolon. No semicolon with the while. Right, just with the do while. Right? Let's think about this in the context of the shootout game, because I wrote a do while loop, right? The do while loop was a game loop, right? The do says play the game, and then while the user wants to keep playing the game, loop back and do it again. Right? Notice there wasn't a check at the very beginning. If instead I wanted to be like, hey, I have this cool game, do you want to play? Right? Then I would have used the while loop, because I'm going to check at the very beginning and then run the game. Here though, I wanted us to play the game and then check to see if they wanted to play again. Does that make sense, the ordering? Right? So the while versus the do while is about where do you want to check? Do you want to check before you loop? Or do you want to check after you've already iterated one time, right? You looped one time. The while says check before you ever loop. Do while says check after you've looped one time and then decide if you want to keep it. Right? Which is what all that says. Right, so look at this example. I starts at 15, right? But there is no check. Right? So I is 15, we go to the do, there's no check, so we see out I, which is what? 15. We output a 15 and a space. 15 becomes 16. 16 is 16 less than equal to 10? No. Right? So how many times did I iterate? Once. But will I iterate twice or 3 times? No. But I will always iterate one time. Do I will always iterate one time. That's the difference. Right? If this was a while loop with the while up here, I would be 15. 15 is not less than 10, so I would never iterate. So the while loop says, right, no guarantee of iterating. Do while, guaranteed to iterate at least one. Make sense? Press on that? All right, we'll go to the do while example. It's super exciting. It's the same thing. Right? The only difference is this time, right, the do is on the top and then we have a while on the bottom. So when I run that, right, if I want 10 greetings, guess what? I'm going to see 10 greetings.
Oh.
Right, but, right, if I say -1 greetings, right, I still get 1 greeting, right? You know, I think I'm really one. I still give you one because the do while always does one time, right? So always run your loop code one time. Make sense? No. Okay, so we have a while, we have a do while. All right, let's talk about the for loop. All right. The third kind of loop we're going to talk about is the for loop. The for loop allows us to loop a specific amount of time. Do whiles and whiles are great when you don't know how many times you want to loop. For loops are great when you do know how many times you want to loop. We're going to get into lots of places later this semester where this is the loop that you're going to use because you're going to want to loop 5 times, 10 times, 20 times, and you'll know how many times that is. It looks like this. We have the keyword for. Notice in the parentheses, instead of it being a Boolean expression, we actually have 3 things. Okay? We have this initialization action, and we'll talk about that. Semicolon. Then we have the Boolean expression, that's our check. Semicolon. And then we have the update action. The update action is the thing that will eventually make the Boolean expression be
False.
false. It's the thing that will eventually
It's
make
like
the
the
Boolean expression.
increment.
No, they're not functions, they're just special like locations. So let's talk about it. Right? The initialization action is what are you going to use to count your iterations? Okay? So you're going to create a variable in the initialization action, set it to, let's say, 0 or 1 or the number if you're counting down.
That's your variable equals whatever, and then you're gonna check how many times you want.
Exactly. So a lot of times you'll say like I equals 1, or very often you'll say int I equals 1. You'll create an I variable, set it to 1. I for iterator, right? It's going to iterate through my loop. Right? It's the thing that allows me to count.
Imaginary eye.
By convention. By convention.
That's just kind of like what people, it's like log-based and it's just understood.
And if you have a for loop inside of a for loop, you use I and then you use J. If you have another for loop in there, then you use K. Very profound, right? We just move down.
It's like the etiquette.
Move down the alphabet.
Yeah.
About when you get to Z. You get to Z, you've nested like 15 loops, and you probably have force problems. That's all.
Some crazy game, you're just checking damage modifiers.
But you would never see that many nested in the same exact spot. Okay. That's the initialization action. After that comes the Boolean expression, which we know. Boolean expression, check to see if it's true or false.
And that's the amount of times it'll go, because you're gonna increment or decrement it.
Right, exactly. So if I starts at 1 and I go less than equal to 10, and I'm going to increment I by 1, it's going to loop 10 times. Right, so for loops are all about knowing how many times you want to loop. It's important for us to kind of realize what that is. Update action happens at the end of every loop. Okay, so you do an initialization action, you check the Boolean expression to make sure that you actually go into the loop. Right, you run the loop, and then you do your update action. Right, that's your I++, or your I minus minus, or your I plus equals 2, right? You're going to go by 2s or whatever. So for example, here's I++, right? There is no semicolon at the end, so don't throw it in. Right, so here's my example. Right, sum is 0, I equals 1, I less than equal to 10, I++. All right, and we're going to add our sums together. What this loop is doing is it's going to add all the numbers from 1 to 10 together, and let me know what that answer is. Right? For those of you that love math, right, I'm doing something right like this. All right, you put the 10 up here, I don't really even know. I equals 1, something like that, right? You're doing the summation of the numbers from 1 to 10. Nobody know, did I do that? We're close to correct.
I don't know.
You guys don't know. I must be right. It looks yeah, close enough.
I don't even know what that is.
Right. Well, don't worry about it then.
Same.
Right. So let's see.
Somewhere in there before that,
I anti it in the for loop. Right.
So you don't need to use, because this confused me forever last semester for a minute there. I is just your iterations. You don't need to use that in your for loop because you're actually having your initialize.
Most of the times you don't use I in your for loop.
Right.
I am because I'm adding the numbers from 1 to 10. In your lab today, you're going to output numbers from 1 to 100, and since I is the thing that's counting,
Right,
it's
right.
the thing that you'll output. So a lot of times you're not using I is just the thing to help you count.
Right.
Sometimes you need to use the thing that you're counting with, sometimes you don't.
That was more just like, it stumped me for a minute there until I had my epiphany and finished my project.
Like, oh, I don't need that.
Yeah.
It just counts. I is super boring. It just counts.
Yeah.
In this case, it counts 1 for the first iteration, and then it'll be 2 for the second iteration, it'll be 3 for the third iteration, and 4 for the fourth. Right? Until it gets up to 10. It will do the 10th iteration, then I will become 11, because, right, I has to be at least 11 to end my loop. Agreed?
Once I figured that out, my box went.
Yeah, it went the right way.
Yeah.
So let's look at this. We have sum, and we have I. Right? Sum as a variable starts at 0. Okay? The next one it goes my for loop. This loop says, create me an integer called I and give it a value of 1. Create an integer called I and give it a value of 1. The next step is to go to the Boolean expression. Hopefully you wrote your for loop correctly to where you're actually going to loop. There is no guarantee that a for loop will loop though, right? Because if I said int I equals 100, right? 100 is not less than equal to 10, so it won't loop. Okay? But if you're writing a for loop, it should at least loop one time.
Which would be a logic error?
Probably.
Where would you, yeah?
Yeah, just a dumb error. Is 1 less than equal to 10?
Yes.
Yes, okay, so here's the weird part about the for loop. You don't do the update action. The update action happens at the end of the iteration. So in fact, I do this one time, then I do my check, and then I go into my loop body. And my loop body says sum gets assigned sum plus I. Well, the value of sum is 0. 0 plus 1 is
1.
And I store it back into sum, right? So 0 becomes 1. That ends my iteration, right? That's the end. Close the curly, I'm done. Right? I go up to the update action. For loop says I go to my update action. So I finish this here and I go all the way over here. What happens to I?
It goes up 1.
Goes up by 1. So I becomes
Second
2.
iteration.
Okay, where do you think I go now? Back to the beginning of the for loop, right? To the Boolean expression check. Because I don't want to reset I to 1, so I'd be stuck for forever. Right? So I go back to the check. Is 2 less than or equal to 10?
Yes.
Yes. Right? So 2, so we go into my loop. Sum becomes sum plus I. Well, sum is 1, I is 2, 1 plus 2 is 3. 3. So sum becomes 3. Right? That ends the for loop. I becomes 3, and we go back to our Boolean expression check. Is 3 less than or equal to 10? I, so the answer is?
Yes.
Yes. So sum becomes sum plus I. 3 plus 3 is 6. That ends the for loop. We go to the update action. The update action just increments I by 1, so I becomes 4. Go to the Boolean expression check.
6 plus
Right.
4.
Right. 6 plus 4 is 10. All right. So hopefully you're seeing that when you come down the code, you do your initialization action, you do your check, and then you're like stuck in this circle. All right. You're stuck in that circle until what?
Until it's false.
Until this Boolean expression is one. So hopefully you realize this becomes 10, this becomes 5, so this becomes 15. And if I kept doing that, I think you get up to 55.
Well, 15 is not less than or equal to 10.
Yeah, I'm pretty sure it's not.
But that's sum, not but I'm summing, right? I'm already above 10. All right, so I keep going, right? 10 plus, or 5 plus 10 is 15. 15 plus 6 is 21.
But doesn't it check the
21 plus 7 is
Boolean,
28.
well, the Boolean expression?
Plus 8 is 36.
Oh, because it needs the iteration to go up.
Plus
Okay,
5
sorry.
plus 10.
Yeah, iteration needs to go to 10.
The iteration has to go to 10, not sum, right?
See,
It's
I had
very
problems with
important in for loops that you don't change I in the body of the for loop. If you change I in the body of the for loop, right, your whole counting mechanism is off. Right? If you're changing I in the for loop, you're probably doing something wrong. There are cases where, right, what you're doing is important, but probably not right now. Right? Changing I in the for loop would be wrong. Because I is changing in your update action. Right? That's where it's changing. Right. And very certain. Probably in those circumstances, you probably would rather use a while loop. Right? Because while loops are more available. All right, let's look at this. For loop. Here's my basic for loop. Right. For, right. Normally you would use I, I'm not using I, right? For number is 10, number greater than or equal to 0, number goes down, right? I'm starting at 10, I'm going greater than or equal to 0, which means number has to become -1 before the loop ends. Does that make sense? Number has to become -1 before the loop ends. So if I'm starting at 10, I have to get to -1 and number goes down. The first time it's going to say t minus 10 seconds in counting. 10 becomes 9, t minus 9 seconds in counting, all the way down to t minus, well, 0 seconds in counting. right? 0 becomes -1. I do my check, -1's not, right? Greater than or equal to 0, so I don't go anymore.
And
The
then
last one, I'll say t minus 0 seconds. Which doesn't really read nicely, right? But we'll just show it. There's a reason why I don't have it read nicely.
would you just change your number to less than or greater than or equal to 0 for 1 or something?
Bring it all the way down to that, and then I got t minus 0 seconds.
So if you wanted it to say launching, like right after you would, that would be your next line after loop.
Right. So probably my recommended way, which is not the way that I'm going to show you. My recommended way would be to change this to 1, right? And then after your for loop, you would see it out what? Times that. Okay. Times that.
Launching. Because SpaceX just
We'll do blast off here in a second.
caught that thing with the net.
All right, run it, and now we go t minus 1098 cents to 54321, and then times out. Right? But I want to show you, not just for loops, but any loop that you can put if statements. You can put, right? You have to put other loops inside of it, but I want to just show you what an example of that looks like. So here's the same for loop, but I have an if statement, and as long as the number, or if the number is 0, I say blast off. If the number is not 0, I say t minus whatever. T minus 10, t minus 9. Right? Really just showing you that inside of a loop, you can have if statements. Okay? Inside of if statements, you can have loops. Inside of loops, you can have loops. Inside of if statements, you can have if statements, right? They all nest so long as you have your curly braces set up correctly. Okay, you're gonna have to do that. In your shootout game, you're gonna have the game loop. Inside the game loop will be the round loop, and then inside the round loop, you have your if statements to like check all your choices. Right? So you're gonna have nesting, right? You're gonna have, and all that's gonna be inside of main, right? You're gonna have main, loop 1, inside of loop 1 will be loop 2, inside of loop 2 will be if statement. And so that's gonna be set up. Anyone knows what happens? So there's that for loop. Anyone know what happens if I forget to say int number? What is gonna happen? Error, right? The error is gonna say what? Number was not declared in this scope.
You would have had to do like int number beforehand, or
Either int number beforehand, or a lot of times because we just use I to count the for loop, we'll just do int I right from the
with I, can you write it without int I?
No.
You still have to.
Yeah, so to fix this, I would go to my for loop.
Oh, because in Java it was var I equals. Oh, okay.
And so here, numbers kind of take into place.
And I would recommend just using that. 1 is shorter, 2, that's 5 minutes. I didn't want to do something fun because we can, and this is a coding class, so, right? We don't want to write. Let's just write here. So everyone get that, right? Numbers and characters kind of go hand in hand, right? They kind of interact with each other. Agreed? Right? So you do something like this: character letter equals capital A. Right? And remember, if I add 1 to my letter, what am I going to get? You don't remember? B.
Capital B.
Right? Capital B, and then I'll get a capital C, right? And so I can actually use a loop to kind of loop through all the letters of the alphabet and just output them. Right? Sounds fun to me, maybe not to you, but it's going to sound fun to me. So I'm going to loop while my letter is at least what? Z, right? As long as it's Z, I'm going to see out my letter, right? And then what else do I need to do? Move letter to the next place, right? So letter, not header, letter plus plus. Does this make sense? My letter starts at A, while my letter is at least Z, I'm going to loop, right? And I'll put the letter, and every time I'm going to increment the letter. A becomes B, becomes C, becomes D, becomes Z. Well, Z is equal to Z, so that's fine. So I output a Z, then Z becomes whatever the next thing in ASCII is, which I don't care about, right? But now it's not, right?
Should be
less
than.
Yeah. This would not work, right? I ran this, we just didn't go out. Right? We're going to loop while it's less than Z, because Z is the biggest of the things. Right, and there I get, right, the letters from A to Z. Was that worth the 2 minutes of your life?
Sure.
Put a lowercase z, would it take you to Broadway?
Yeah, sure. Right, so if I do a lowercase z, that's not mine, it's over here. Alright, so if I change this to a, no, so I change this to a lowercase z, then you can see what those characters are in between. You get A through Z, then you get square bracket, slash, square bracket, caret, underscore, tick mark, and then you get A through Z. Right? So those are those characters that are between uppercase and lower.
You know, what is it called?
ASCII, ASCII.
So there's a bunch that are left blank, they're called reserved space. 2017 version they added to What do they do when they run out of filtration?
You think they are variable? So, this is a character by default or unsigned character. No, they're signed characters. So they technically go -127 to +127. Right now we only use 0 to 127. There's still that negative that we can use. And then there's extended ASCII, which uses more than one byte. It's all like 30, 31, 32, something. We're not blank, and then they double blank. It's always new things to do. All right, let's talk about problems with loops, and then we're going to do a little activity. All right, let's talk about pitfalls with loops. I'm going to talk about two main pitfalls that people have with loops. One is the extra semicolon problem of a for loop. All right, here I wrote a for loop. Right, I start at 1, I go less than or equal to 10, and I increment by 1s. Right? Anyone know how many times I'm going to loop? Say louder. 10 times, right? Start at 1, less than or equal to a number, I'm going to loop that many number of times. Okay? So I'm expecting it to say hello how many times? 10 times, right? Except for the fact that I say for loop problem, I say what? Extra semicolon. Where's the extra semicolon? Everyone see that right there? All right, so far you've gotten away with just putting semicolons wherever. Right? I got to compile, let's just put semicolons. Okay? Well, if you don't have curly braces, even on an if statement and now on loops, if you don't have curly braces, how many things get looped?
Everything.
Well, just one, right? You get one thing. Curly braces give you lots of lines, right? No curly braces give you one thing. Okay? And so what's looping is the semicolon. Okay? So the loop still loops 10 times, but it doesn't loop hello 10 times, it loops the semicolon 10 times. Right? That's called the empty statement. Right? You can just throw semicolons all over the place when they go. Right? They're a statement, they just don't do anything. Right? Yeah, it's not good to do. Right? So the loop loops the semicolon 10 times, so then how many times does hello actually output?
0.
Right? A lot of people say 0, but right, the answer is 1, right? Because this loops 10 times. When that's done, it'll just run the next line of code. Right? The next line of code here is just hello. This will probably show up on your test.
So it's the semicolon at the very end outside the parentheses?
Yes. That's not all.
What if you just got rid of that? You don't have curly braces.
Well, if I don't have curly braces, it will still run, it will loop the next line of code. Right? For loops, you can get away with not having curly braces because your update action, right, to make your Boolean expression false is in the parentheses. So you might just only do one thing. Oh, why? Put curly braces. Right? Do as I say, not as I do. Right?
That's it.
Exactly. Loops don't terminate until what?
False.
Until the Boolean expression is false. So if you never make the Boolean expression false, your loop's going to run for how long? Forever. Right? They're called infinite loops.
Unless you had a break.
Unless you had a break. But don't breaks are actually bad. So loops don't end until the Boolean expression is false. So you want to make sure that at some point that will become false. Make sense? Right, it's super easy to write a loop that won't ever stop looping. Right? Here's my loop. Right, number is 5. Well, the number doesn't equal 2, I say odd, and the number goes down. Right? So 5 is going to become what? 3. Right, so 5 minus 2 is 3. I'm going to store it. Then 3 is going to become what? 1. 1 is going to become -1. Right, notice it never hit that condition. Right, it means in this right, example, it has to be 2. 2 is the only time that my loop will end. Agreed? And if I'm going down by 2s and my number's odd, I'll never get an even number. So my loop will run how many times? Forever. My loop will run forever. Make sense? Right? Never, ever, ever use like equality or inequality in your loop. Right? Use greater than or less than, greater than or less than. Just in case you ever go too far, but you screw that up a little bit, it'll still stop. Right? If I said, well, a number is greater than or equal to 2, right? Then it would have worked, and once it became 1, well, 1's not bigger than 2. Right? So it's always better to do greater than or less than.
What if you were making like a Minesweeper game and you wanted exact?
It is exact, right? So you can loop sometimes if, right, while the user's input's not yes or no, right?
Usually that would be nested in a condition. It's not running unless there's like something. Okay.
All right, loops cause problems because now, right, you're taking code and now you're going to do it many times. Right? Make sure the code you're looping is correct. Right? Otherwise, you're going to loop that code over and over, which you don't want. All right, watch out for those pitfalls. Let's see if I want to show you. Not too worried about these. You're gonna work through those in your lab. I do want to show you this one. I made a short. Right, shorts are smaller than integers, right? Shorts go from negative 32,000 to positive 32,000. Everyone remember that? Right. So there's my short. It starts at 1. While x doesn't equal 12, I'm going to output x, but now I'm modifying x by 2. So x will be 1, then it'll be 3, then it'll be 5, then it'll be 7, then it'll be 9, then 11, then 13. All right, everyone agree? So it's an infinite loop. So I max out short. What happens when I max out short? What happens when an integer gets to its highest number? What happens when you have 1 to it?
Resets.
Resets to its lowest number, right? So I'm trying to show you that while logically it's an infinite loop, right? It may be that it will end at some point. And in fact, instead of adding it by 2s, let's add it by 3, so it can go odd, even, odd, even. Let's make sure this happens. 4, 7, 10, 13. Okay, we're good. All right, ready? Loops always look amazing too.
Oh.
It goes positive and then it goes to negative. Might have peeked out. It does that.
The clock.
Whoa. Oh, like you're like in a hacking thing or something. Put all the numbers. Don't you guys see? Right? They're gonna measure. Anyway, everyone, good. Why it went negative, right? Because it hit positive 32,000. Let's scroll up. That's probably prime 912. Whoa. Okay, if you're getting queasy, look away, please. I don't want to clean anything up. I want to get to where it goes negative and positive. Over there? Oh yeah, there we are, right? So we get to 32,767, and then adding 1 to that gives us what? Negative 32,766. Then we start counting up again. We'll probably that loop will eventually. Right? If I make this smaller, exactly. This is Cloud9's like processing power. So when I run an infinite loop, the process shares the go. Well, oh, it finally made it all the way. So I just wanted to show you, right? Because I was going odds, right? My infinite loop actually ended. Does that make sense?
Yeah.
My infinite loop ended because the integer circled around and eventually became the number that I was supposed to stop. So while logically the infinite loops realize that sometimes they end. Right? So let's not make it end. Right? Those are pitfalls. Let's add it by 2. But I just want to show you what happens to your CPU when you do this. I don't recommend it. Okay. We'll see that. Normally it updates to those full green. Might be in there.
Here's the first.
Memory speed up more memory now. Oh, there you go.
Oh.
We're maxed out.
He's like, please don't.
Because when is the program going to end? Yeah, it's taking up all my processing power, or it's trying to take as much processing power as it can.
It's already
I
done.
really want to
positive.
calculate this number. I was gonna calculate this number for when? Forever. Yes, question.
So
114%.
when you do this to the cloud servers, they don't ever cut you off. They'll just loop it forever.
I'll probably crash at some point.
Did it just crash?
I hit stop.
Oh.
So I made it crash. But,
Save someone's
I
job.
mean, right, it's not, we're not talking about a server, we're talking about a virtual server that's like a tiny little piece of the processor that you need. So you're using up that space.
I'm using 114% of my processor. 114%.
There are ways, advanced C++, you can get into threading and multi-core stuff, and you can put stuff on certain boards. Yeah.
Parallel programs like C++.
Yes. Which is pretty cool.
So you showed us this diagram of what the two are and so curious from the wet C.
I have to look it up. So I don't know. There's a couple things. That like brand stuff, but they added new stuff and stuff like that. Alright, we're gonna go to loops. We have while loops, we have do while loops. The difference being while loops are guaranteed to run how many times? Try to throw you off. Are they guaranteed to run?
No.
No, right? Do whiles are guaranteed to run how many times?
What?
Once. For loops are used when you know what?
How many
How
times?
many times did it do? You do that?
Yeah.
Okay. Let's talk about FizzBuzz. FizzBuzz is one thing that you're going to do in your lab today, so we're going to talk about what it is, so that way you'll know how to write that. FizzBuzz is a question, right? It's like a classic programming question when you do a job. I thought people didn't do it, but I've had students still tell me that they have that question on programming interviews. It's like super basic. I'm not saying that you guys are super basic, but like a couple weeks into your first semester level of programming, you should be able to write it. So it's like a super basic, like, do you actually know how to program or are you just lying? Right? By the end of today, you won't ever be lying, right? You'll be like, I know at least how to do this. Okay? Make sense?
No.
All right, so let's talk about FizzBuzz is. FizzBuzz is a way of counting, okay? But you don't count normally, okay? You replace certain numbers with either fizz or buzz or FizzBuzz. Okay, so numbers divisible by 3 are 3, get replaced with fizz. Numbers divisible by 5 get replaced with buzz. And then numbers divisible by 3 and 5 get replaced with FizzBuzz. So if I was going to count to 15, right, it'd be 1, 2, fizz, 4, buzz, fizz, 7, 8, fizz, buzz, 11, fizz, 13, 14,
FizzBuzz.
FizzBuzz. Does that make sense?
Yeah.
All right, so you're going to write a program that counts from 1 to 100, but it gives you all those numbers.
With our lab.
Right? That's question 3 of yours. How do I know a number is divisible by 3?
You can check it.
You can check it. How do you check it?
With modulo?
Divided by 3.
Yeah, if you divide it by 3, though, that's just going to tell you how many times 3 goes into it. That's not that helpful, right? Because you don't get decimals back, right? Especially like the mod gives you, right? So if I take some number and I mod it by 3, in order for it to be a multiple, that value that the mod gives me should be what? 0, right? Meaning that it went in evenly, right? Because multiples go in evenly. So if x mod 3 or whatever, right? I mod 3, probably for you, is 0, then it's a multiple of 3. And you're not going to output the number, you're going to output fizz. If it's mod 5, you're going to output buzz. And if it's mod, either mod 3 and mod 5, which is also just mod 1. 15, right? Then you'll take this one. Does that make sense? That being said, FizzBuzz is also a game, so we're going to play the game first. Feel good about ourselves, and then we're going to rank. We're going to do a lot of fun activities. But we're going to play FizzBuzz. Okay, so everyone stand up. Trying to figure out how we want to make a circle. I guess if you're...
Oh my god, no. We're getting a circle in there.
Yeah, if you're in the middle, and you're not the last 2 people in the middle, you should probably try to get in the circle. So we're going to circle around the whole outside of the room. So you can be standing on the outside of the room, or front or back of the room. Does that make sense? But you 2 can stay there, or the 3 of you. You just know, like, you have to know who's after who. That's all we need to know.
Get up the silent circle.
All right, make sense? Alright, so what we're gonna do is every person in the class was gonna say their number. So we'll start at 1 here and we'll move all the way around. Okay, first round's practice. After the first round, if you say it wrong, you sit down. We're gonna try to get to 100 as a class. So we're all in it together, right? So even if you get it wrong, don't worry, we're all in this together. You can pull for the rest of your class. But I'm gonna speed it up eventually. Make sense though what we're doing?
Yeah.
If it doesn't, we'll know after the first round. So let's start here.
1,
2, 4, 5.
Fizz.
Yeah, it's a biz, that's good.
6.
No, so that would have been 7. And then, so he's 7. Yeah, 8.
Fizz.
Buzz.
11.
Fizz. 13.
Uh-huh.
14. There's Buzz.
16. 17.
19.
Which is a buzz.
Oh, what?
You're okay right now.
I hate this.
And 2.
23.
Yeah. You never feel so less confident about just saying like a number. Hopefully, we're gonna do the whole first round again, so hopefully no one sits down. Right, the order's the same, whatever number you said, as long as you said it correctly, it's the right number, okay? But after that, you know, I'm gonna start making people sit down. And I have my cheat sheet, because my brain doesn't work that fast either. You're gonna make your own cheat sheet, but in lab. Right, let's go, here we go.
1.
You just wanna sit down, huh? Oh, we started at 1 again.
Oh, you're at 1?
He like freak out.
He's like,
my own cheat sheet.
Alright, should we go on break? Yeah, let's start again.
1.
Fizz. 4. 7. Fizz.
Buzz.
11. Fizz.
13.
14. Fizz. Buzz. 16.
17.
19.
Buzz.
Fizz.
17. 23. Fizz. Buzz.
Well, no, you're fine with it. Hey, there we go. Fizz buzz.
Fizz. Buzz. 31. 32. Fizz. I said Fizz.
You're down 34, it's 34.
Buzz.
Oh, Fizz. 7.
I'm not a math
You're
person.
down 38.
Fizz. Buzz. 41.
42.
Fizz.
43. 44.
Buzz.
Fizz buzz.
Yes.
46.
Failure never tasted so sweet.
47.
Fizz?
I'll tell you, sit down if you get it wrong. Be confident. That was correct, it wasn't Fizz. Which was 48.
He's like, yes, thank you.
Oh, 49. Fizz buzz, perfect. Oh, sorry, 50, just the buzz. Okay, if you pause too long, I'm gonna make you sit down, then I take away your arms in a minute. So that was 50, which was a buzz.
I feel like we should move that one.
Not Fizz.
53. Fizz. Oh, it's me, that's Buzz.
There's a 58, move on.
Wait, he was what?
58?
He was 56.
He was 56.
Yeah, because I was
56.
58 in my head.
Oh, so he was a Fizz, either still, that was a Fizz, 57, now we're on 58. You get it nice and easy, 58.
59.
Fizz Buzz.
61.
62. Fizz. 65. 4.
64 is good.
Is
57. 68. Fizz. Buzz.
Now take away all the ums. And the quickness. Here we go. That was Buzz, which was 70.
71.
Biz.
74.
You're done. 76.
77.
Oh, so, Fizz. 79.
Buzz.
Fizz. 82.
You heard him though. You're done.
80 fizz.
84.
84, which is fizz.
86. 87.
Which is Biz? Faster.
88.
Fizz.
No, heard him. 89.
Fizz Buzz.
Biz Buzz. Nope, 91. Nope, 92.
Biz.
Yes, you got it right.
94. 95.
Buzz.
97.
98.
Fizz.
Oh, we ended with the buzz. We'll take it. We made it. Way to go, class. Everyone give yourself a pat on the back. Okay. You great.
Because it's 3 after.
And your goal
3 after.
in question 3 is to write the Biz Buzz.
Oh my god.
So you're talking enough ace coding interviews, right?
Ace coding interviews. Count to 100 using Fizz Buzz and Fizz Buzz.
Permanently turn off some.
I quit.
Let me just show you the lab.
Not do, man, to save my life. Her teacher will
All right, question 1 and 2 are all about working through the syntax to figure out the answer. You can then use the syntax to check it, right? You can use Cloud9 to check it. But work through it first and see what happens. All right. So 1 is an A through E. 2 is just an A through C, right? 1's all about while loops and do while loops. 2 is all about for loops, right? Pay attention. The extra semicolon may here, so we had some. Question 3, right, is write Biz Buzz, right? That needs to be in an if statement, agreed?
Yeah.
Right, which is going to be inside of a what kind of loop? For loop, probably, because you know you're going to do 100 numbers, right? So you should use a for loop, you know how much. And question 4, write a program that reads in exactly 10 integers and outputs the sum of those numbers. Similar to what I showed you in class, but in class I added via I. Here you're adding via user input. So you're going to loop, and in your loop you're going to get 10 inputs. Right? You're going to add those 10 inputs together to get your sum. Did you create 10 variables?
No.
They say no.
No.
1 variable, right? What you're making is a running sum. So every time you loop, you're going to add to the sum, so at the end you'll have a total sum. Right? We don't make 10 because then if I wanted to do 20 or 30 or 40, then I have to make 20, 30, or 40 variables, right? We want it to work for all numbers. I'm just having you do it with 10. That make sense? All right, so you enter 1 10 times, it should say 10. If you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you saw that answer was 55. All right, so there's some data sets you can use. Right? So it's just 1 through 4. Seems like an easy lab, right? Just 1 through 4 for lab, all right? Which you have an hour to do it, you'll be great, right? And then also, right, keep working on coding assignment 2. Right? Or you can challenge yourself and start it a week from today, after your test.
Oh.
You like that kind of pressure.
Oh my God.
You work the best under pressure, just don't do it yet. Right?
Do it the night
I'm sure it'll
before.
turn out real good for you.
It's like 12, 11:58. Turn it in.
Just start doing it at 11:58. Yeah, I got this.
All right, that's what we have going on.
Copy paste.
I finished the program. Copy paste.
No. Someone wrote this.
Started at 11:58 the night before. Copy paste done.
Weird and
Finished.
inefficient. Nice.
Like,
With this bus, I have no idea. I didn't.
No, I was.
Someone smarter than me. I actually played it and sharp.
Are you good? You want to take care of me?
And if you're into checking your answers, you're welcome to borrow my Biz Buzz
Oh my god, we actually have to make one of these.
Yeah, you gotta make it. It's like, I am dropping it back.
I would if I didn't need it for my majors.
Just change the name.
I can't change majors. It's my life's purpose.
Oh, you're in a conundrum.
Yeah.
Some of mine are math majors, and yours aren't our life purpose, and we still have.
I'm a level designer. I am a game designer. But I'm not a mathematician.
I'm not a mathematician either, right? They show some lines on the board.
No, I've worked in the Source SDK. So that's why I need to learn C++, but FizzBuzz makes me want to actually kill myself.
Could just be. Well, the computers are super slow, so Chrome itself should open slow. Yeah, I'll be back in a second.
Yeah, you're good.
Huh? You can do anything because it's just while 0 out X, but nothing's going on, so wouldn't it just be X? Yeah, just be X. It's it'll output X still. Actually, no, it won't. Because, yeah, it won't. No, like, but there's no pin either, right? Yeah, it doesn't display. There. Yeah, it won't display. Hit the backspace key.
Yes, that's what
Because I think a lot of math people, like if you're just like a statistician or actuary, not all your stuff is all computers. Does that make sense? But I'm
No, it doesn't display.
So for each, it just outputs 14 X's, right?
Yep. You are correct, Chris.
And for your B, doesn't that just put X forever?
What on B? Which one, for 2?
For B. 1.
Oh. Y isn't, while Y isn't Y. Yeah, probably. I don't think so. Maybe it's just once. Because it says while Y isn't Y. So
in the while, it's not like it's just you're just C-outing X, but Y could never equal Y. So it could
it'll still do it one time. Because in the do while,
it's just gonna do it forever. Because that's potentially never met. I don't know, I could be wrong.
While Y isn't Y, do the do while. So if Y isn't Y, it would do it infinite. Because it says in the while loop that it's not Y. So it's infinite. Infinity.
Are you agreeing with what I was saying?
Yeah, because it'll do it an infinite amount of times because it says in the while loop, it says Y isn't Y. So if Y isn't Y, it'll just keep doing it.
It's like they do one does it once.
Yep. Nope.
So state.
There you go, Daniel. Damn, Daniel.
It's gonna run this 5 times. What is this? Yes. It's all over the place.
Have 1 match, every year support. That's like kill anyone with this. I'll take them. Like
I think I need to put this
You guys have that? Everyone sign in? Where did that start? Right here.
There's a couple times I haven't gotten it, and I've like left, because I finished my lab, and I'm like, you can always go your way. So,
As long as you sign it once every 2 weeks, you're good.
every 2 weeks.
Every 2 weeks, that's kind of I don't need school. I learn everything on the street.
It's just going. Forever. Yeah, so
you can't use right, but then you gotta switch. Right, because switching is all about equality, so you have to switch on. Yeah, I don't know if you can do that. If I do that JavaScript, I don't even know if you do this. But yeah, I mean, let's see if I can. Get in line.
Get in line. Luke already has it set up.
Okay, stop. I forgot that I left that running. It's up to like 9 million. What the fuck?
How's it?
Yeah, so here. We'll switch on to real. Based on that. So it works like Java and JavaScript. Well, the problem, yeah, it should, because it should evaluate. So just, and C++ won't switch on in your so any other forwards. Right. I want to make sure I'm right.
Okay, for B, which is, I don't know if you remember what you wrote.
Is it Kyle?
For this one, Kevin, when I look at this.
Sorry about that.
Yeah, I'm gonna remind you of your brother. Right?
Yeah, so,
I'm crazy.
I'm just saying.
Yeah, but here it says.
You said you're having a problem with
Just say
writing code and having it, you were having to write all.
So instead of writing hello,
Like-
infinite, just say infinite.
Because he's gonna.
Just the concept of those guys trying to go through that and like.
Well, he grades off of my,
Okay.
answer sheet. My answer sheet.
I just did that in the program by
Well,
saying.
like when we're doing the thing around the class.
Oh, that was
Yeah.
confusing, so.
Yeah, I can't do math in my head like at all. I need a calculator.
Oh, yeah.
Like sometimes
It should be 17.
even just some basic addition.
Well, okay, so it's going lessons.
So
We're going to loop 50 times, right?
When I got
But all the way, so when it's less than 20, so when it's from 0 to 20, which is 20, right? It's going to output X, except when it's not 50.
I come here to Beach, I do my placements, it's new basic math. I had to start over again.
Thank you.
Okay.
Oh,
He
my
doesn't
God.
want to come to classes and even do that.
Oh, my God.
Hey, you know, at least he has it built in.
Well, how did you, don't you need, like, a break in order to take this course?
This is my afternoon class.
I got through a college level.
Or don't you have to take college algebra?
Well, no, well, like there's a bunch of college level transfer math courses that you can take, right? You know, trig is one of them, stats is one of them, and then there was this thing called like nature of math or something. That's what I took, and it's basically like a little bit of everything.
Oh, man.
It's for the people that can't get through anything else, because I tried trig and I tried stats multiple times and I failed each one.
Oh, jeez. Yeah, some people just can't do it.
I know, but
But a lot of
if I
people don't
want to
understand
be
that.
able to be in this field, which is what literally I need to do.
It's a lot of math.
Yes, it's a lot of shit I can't
It's a
do.
lot of math. I'm telling you that.
I know.
It's just that, eventually, what I do in my life is I tend to use statistics almost every day for practice. And most of it's outside of school. Like I play a lot of video games that involve statistics, that involve me doing like a lot of micro math problems all the time.
I mean, like, I guess I have to do a bit of that for Aeon because I'm keeping track of all the stats that I need.
See, that's still something.
Yeah.
You're still using statistics.
Yeah, I know. It's just I wasn't very good at the actual.
But part of the problem is if you say you can't do it, you definitely can't do it.
Yeah.
You want to try to strive for saying you can. But it's going to take some time. It's not going to be overnight. It's going to take a while.
Yeah.
It just takes practice.
I've been in college since 2008. It's taking too long.
You've been in college since
Heard that, bro.
2008?
Heard that. Been in college since 2012.
Oh my god. Well, I wish you luck. I really hope, because it just takes a lot of practice. Some people
Yeah, I
learn
know.
slower than others.
Like, if I was going to do game design, it would be level design, or it'd be like the top level everything together, because the guiding overall vision of a product needs a good game designer to think about all the things in the head, not necessarily specific programming things. That's where I want to be, or on an art team or something. I don't want to be programming an engine.
In a small room with a bunch of people.
Yeah, I want to be able to talk with people that do that, but I don't want to actually have to do it or need to know how to do it to do my job.
Well, you need that piece of paper that says here, which is your degree, basically. In order for them,
Design with an emphasis on art or something.
are you taking graphics design?
Huh?
Are you taking graphics design?
Applied computer graphics design? Yeah, this is the last class I need to get my associates in it.
Oh, cool. Awesome.
So I need this, but I'm amazed I've gotten paid so far, but it's shit like this that's probably gonna kill me.
It only gets worse.
Yeah.
It only gets worse. I'm just.
I guess it's a good thing there's a nearby bridge at my house.
Oh no! Don't do that.
It was a joke.
I know.
Don't mind me. I just spend my life dreaming impossible dreams.
Well, anything's possible if you set your mind to it. Really. That's the wrong one. I opened the wrong lab. There it is.
This one is for X isn't 0.
I'm gonna Control Z and go back. I'm gonna open this in Notepad++ this time. I tried to copy and paste my code, but hold on, let me save. Minimize. Okay. Open this in Notepad++. That'll help. There we go. Okay, Daniel. You want to see what I did? Alright, so I started the value of x. I mean, I don't know why I named it x, but it was easy that way. So I said x is 0, and I made a while loop that checks to see if it's less than or equal to 100, and if the modulo 3 is 0, then it'll do fizz, then buzz, and fizz buzz. And then I said display the value of x regardless if any of these match, and then just add 1 to x, and that's what I did in this program right here. Worked just fine. See, if I go up here, you can see fizz 0, 1, 2, fizz 3, 4, buzz 5. Oh, I messed up. I done fucked. Okay, let me try that again. Let me set the value at 1.
I see, because it's like 9 fizz, 10.
Let me try that again.
Oh.
Oh no! It says it after. So it displays the number, right?
Oh, yeah.
It says 1, 2, fizz, and then it displays 3, and then it says 4, buzz, 5, fizz 6, 7, 8, fizz 9.
Like 3 fizz. That'd be cool. Like, instead of like under it, put like next to it. I don't know.
Well, yeah, what I would have to do is I have to move all this before this, so I have to move all this in front. So let me do that.
No, we won't open anything, right? Just skipped over it, right? So while loops aren't guaranteed to run, so the statement false.
Right there. I'll just comment this out. There we go. It comes after now. 99 fizz, 100 buzz. It did it. This takes a lot of shit. Now what is number 4? Number 4 is write a program that reads in exactly 10 integers output. Sounds like a lot of work. How did he do that? Or what number are you on right now?
Install 2.
Oh, okay, okay, never mind. I need to figure out how to get the.
Number 4?
Yep. Write a program that reads an exact. Oh yeah, I just make a for loop. Okay. For I equals int I equals 1 semicolon.
That'll make one.
Okay, I keep getting errors. I'm sitting right here doing help it.
I'm gonna start handing out cards in class, I'm gonna get one question.
That all starts stealing people's cards.
Yeah, right, you can sell them to other people.
That'll be $15.
I'm good at this class, here, I'll sell you cards.
That'll be $15. Yep. And then I do C out, sum, end line, run program, cross fingers, hope it works. 1. Sum is not defined. I'm gonna kill him.
That is not defined.
I'm gonna kill him. Int. Sum. I'm gonna say equals 0 because if I put anything else, it'll freak out. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. I want it to add them together. Right? Should work.
Increment by 10.
Oh, wait, I got it. I know what I did wrong. I have to put int in front of this. Hold on.
And that's because you're out doing all the fizz and fizz buzz numbers,
Int.
you're not putting like one.
There we go.
So you can find if,
There we go.
right, see, okay, else.
See, now the final answer is
right,
55.
alpha, buzz,
But it adds all of them up, though. It adds all of them up still, so.
Well,
It works.
If, else, and then the else is just alpha, right? Basically, if it's divisible by 3, I'll put this. Else, if it's divisible by 5, I'll put buzz. Else, if it's divisible by 15, I'll put this buzz. Else, just alpha, not. And then the else at the end is your number.
Okay.
Yeah.
I go all the way back to the fucking canvas and turn in lab 8. It's a lot of work.
See out I or whatever you called it. Whatever the number is.
What is this?
Yep. I'm gonna ask him.
Else,
Like
whatever
the breaks and the,
But I
I
have.
don't know what the breaks
Yeah, but
are.
there must be something wrong.
Like, how am I gonna get the computer's guess to get stored somewhere, and then use it as I please? That's my question.
Only doing fizz buzzes.
Yeah.
So I
Whatever
need
you have with the normal number.
So, okay, so I need to see out the number as well. No
When
matter
it's
what.
when it's not any of the others, right? You want to put the
So I need
number if
one
it's
more.
not fizz or buzz or
I need one more L. I need
You need an else. Well, it has to be if else if. So you just need to.
You crush it.
It's going in our condition, if and then else if.
Chris, do you require assistance?
Nope, I already did it. You want me to carry you?
What?
I said nope.
Okay.
Carry you. You carry me?
Else if
You carry me?
else if.
Oh!
Suckers. Sucker.
Does he go up to the first one? Oh yeah, Chris got it so like it doesn't show the 3
What?
for the fizz buzz.
You need help?
How do you do that?
I'm not a shy man. No, what do you need help with?
Oh.
And then check to see, I don't think you're around this.
So this
Oh,
part's
okay.
true, right?
See, what I wanted to do is.
Yeah, so if it flips them.
So either one of those have to be true.
Oh, now you need it to say fizz buzz?
Well, no, it is.
No, the actual one that says fizz buzz. You put modulo
There's a lot of levels of
Yeah, it's
abstraction.
You gotta do a modulo of 15
is what it is.
So my
Oh,
question is,
that's
I
easy.
just started
Yeah.
on that one. X is less than Y. Are we assuming that X is 10 and
Yeah,
Y is
he
20?
put, he outputted the number into my statement, I just outputted it outside of all the
That's for the next.
And it's displaying all the numbers, but
Yeah.
So I assume that if it's being written linearly.
Can we talk about figures?
Values of 10, 20, and 30 until.
I don't need to do that.
Much like a program.
It's fine.
You would have passed that using some statement.
Yeah, so don't retroactively apply them to 1A through B. So you can just
R.
leave those as abstractions. Yeah.
What do you wanna do, run away? Computer's gun is now loaded. It's ready to fire.
So what that does is a loop, and on every iteration of the loop is around the value of I. So first iteration.
So one of these I don't need.
Now,
the 5.
The way we can check that
Is it the 3?
we can check I. It's I.
Let me try.
That means, right, I monthly is 0 and it's really like
I'm just gonna try.
the way that we set that up is it just.
to see where the 3 is. It's only fizz buzz anywhere.
So we're saying give it back, right? Then we don't see out I, we see out. And eventually we'll have the out, right? We don't have the big in 3. Now on this, all of a sudden, look at a little bit better. I'll be at 1.
You're getting it to say fizz buzz?
I got mine to say fizz buzz.
No, it has to say fizz buzz. No.
Yeah, like the fizz buzz when it says module 15. What do you want, Ethan?
Fuck did you get yours to say fizz buzz?
Oh, let me find it. After I stop this program.
Is it the 5 that you don't need?
I think it's this.
Move the order of it, right?
That was the wrong one. It's right here. I copy paste the whole program in here.
Or you could just move the fizz buzz case to the top.
Why are there so many options?
Wait, why am I not getting fizz buzz?
Well, the reason you're not getting fizz buzz, some of you might not be getting fizz buzz, the reason is that if you set it up basically, if, I'm just gonna say divisible by 3, right, you're gonna output fizz, right? Else,
If anything, I would expect to have it fizz buzz buzz.
fizz 5, right?
Oh, I'm not
You
getting
say
that.
buzz, right, then you say else
I
if,
see.
right, vote, right, you say fizz buzz, you good with that?
Yeah, that's basically what I have.
Right.
That's
So
what
the
we do
problem
right
is that code always starts top to bottom, right? So when it says 3, 3 is divisible by 3, so it says fizz, right? And then it gets to 5, right? 5 is not divisible by 3, but it is divisible by 5, so it says buzz. Right, but let's think about 15, the first time you say fizz buzz. Is 15 divisible by 3?
Yeah.
Yeah, so it runs fizz.
And it doesn't
And it's
really.
an else if statement, so it runs fizz and then it skips over everything else.
Okay.
Right, the easiest way is to take this case. Or going complicated, you can say divisible by 3 and not divisible by 5.
Ew. Don't use not.
Two examples to do.
What's the matter with you?
Not use not. It always says fizz buzz, right?
It just says fizz buzz with a bunch of numbers, and it says lost over, and it's fine.
There it goes. Yeah.
5 on 15 itself.
Got it.
Just.
It still says every number?
Almost always.
Huh?
It does for like every number.
Yeah.
Oh, there it is.
Fuck it.
Okay.
Go to the top.
Don't scare, son.
Go up. Yep.
Apparently I was wrong.
No, I don't know. It says that it's 3. And
Oh, wait. 5 isn't
There's
happening.
no
though.
count variable in there at all, so.
Oh, wait, you know why? It's because I didn't fix this one.
No, it's 6 plus 5 is 15. But there's no count number in there, so.
Yeah, well, count, it's like, if you
No, I
place
would
count
not
at 0, that's the same thing, right? So they
See?
add
Look,
something
that's,
there.
that's fizz, that's buzz, that's 10.
So.
9 is fizz, and suck it, nerd. How does it want me to do this?
Good job, Chris. You have successfully passed the first test.
You don't know me.
You're hard.
Now I can go intern a build or something.
What, I can enter somewhere, like, do you know how to do loops? Well, they get functions, then it'll be good.
Oh,
I did
functions.
do a function.
Yeah, well, yeah, it is.
You're like, kinda.
Good JavaScript.
Luke. Oh, man.
Very similar to what I did. But you were taking input from mine. So what I did in the slides, I just added I to the sum. Maybe it is I. Or what I'm asking you to create input from.
What is number 4? What?
Yeah, what does it say? Maybe it's bad English. Right. So it's gonna read in, right? That, so you're looking for user input. Things like that's happening. I spoke with the Simpsons episode where Homer Simpson says, "We fail in English, that Ron, hand up, or we good?
Don't know what that means, don't know how it is.
Right, man?
I don't know. I don't know.
Is it fixed now, or you want some?
No, I need help on the assignment 2.
Okay.
So my question is, I was looking at this picture, and I can make some sense of this, but I'm just trying to figure out what this means. This question mark equals computer reload.
So the question mark is you have to create a variable, and I don't know the name of your variable.
Oh, okay. So what I did for my program is, it's right over here. So when the game starts, I make a variable called game_set, and this knows that this is when the game starts. So it asks the question, random stranger, you need to reload your gun. So you press R, it checks if you pressed R. It adds to the player state, which the player state is if your gun's loaded or not. And then it adds to the computer state, which the gun reloads for the computer.
Okay.
And then the game set is increased by 1, so this never comes up. So then it goes down to this if statement. And so then it says, your gun's loaded, the computer's gun is loaded, what do you want to do now? And so then I check for block or shoot. And then I'm just wondering, do I put the random numbers for the computer here? Or do I
No,
start?
that sets it up, but every round, so basically, right, because this is
Do
only
I have to make another loop for every round that just duplicates itself?
Yeah.
So this wouldn't be necessary. I had to put this in some sort of loop.
Right, exactly.
So the
This
loop would
here.
start right here.
Right, the loop would probably start there.
Okay, and then the round starts where
And then the
it
round
checks.
starts. Mhm.
It checks to see, for example, like I make player state equals 1, which means it'll display a message that says your gun's loaded or not. But then how would I? So I have to store the.
So like in this state, right, where the player state is 1 and the computer state is 1.
Yeah.
So here you're getting the user's choice, which is good, right?
Yeah.
And then after that, you would just generate the computer's choice.
Oh.
Right.
So I would make the random number generator right there.
Yeah. So you would just comp choice.
Yeah.
Not choices, but just comp choice equals rand.
Do we have to push everything that we do to you for you to see it, or do we already do that one time? So everything.
No, you have to add, commit, and push, or I won't see any changes. Get add first though.
So then
Get add
modulo 2 here.
if that's what I don't know what the choices would be.
Oh, I know it
Or
would
it
be,
would be 2 plus 1.
It would be plus 1 because his gun's already loaded. And then
Exactly.
And then I put the choices up here, right? Right here. So how would I check these?
So then there's comp block and comp shoot, right?
Yeah.
So we just generated 1 or 2, right, to block or shoot, right? And so so if the state is that, you'd probably have like a else if the state, right, as the states change.
Okay.
And then down here.
There would be a boolean that compares them, right?
Yeah, and so this would right here, you probably start your big boolean, right?
Yeah.
And the big boolean could start as if, right, because I named it comp choice, right?
Yeah.
If comp choice is equal, and I'm just making it up, but okay, all right, what did you call it? Block?
Yeah, comp block.
Comp block, okay.
Yeah. Oh, okay.
All right.
Yeah, that makes more sense.
Is it
Because
capital C comp block?
It's camel case, so it starts lowercase and then it's
Oh,
capital.
there it is, comp block.
Yeah.
So if the computer's choice is block, right, and the user's choice, which I think you just called choice 1. Does that sound right?
I don't think I named it that. I named it player. I'll make it. It's probably player choice.
All right. So and if player choice.
Yeah.
All right?
And then I have to make like
Right.
9 of those because there's 9.
Right, so if
9.
the chair's player's choice, let's just say they also chose block, right? I'm just making it up,
Okay.
right? So then you would handle that choice, right? And there you flavor text, right?
And then
You
I would
both
say,
blocked.
you both blocked, you can't do anything, so now.
And then it'll
so-
loop around, and
and
then
then-
it'll have them choose more choices, right?
And so the game, the state would stay the same until they shoot, which I would say the player state is subtracted by
exactly,
1.
exactly.
Okay, now
Does that
I
make sense?
Yeah, now I
So
have.
all that gets looped, right? So you need one more loop.
Okay, so would this loop happen after the prompt?
Well, I think
or would it happen before?
your loop is gonna start. Well, let's see.
Is it gonna start way after this whole loop here?
Well, it's okay. So you kind of like built in the beginning of the game.
Yeah.
Like you made them reload, right?
Yep.
So which means that the loop would start here, right?
Okay.
So you'd have a do loop that started here, right? Because really you don't want to loop that every time. That happens once.
Yeah, see, that's why I put,
Right. Mhm.
yeah.
But actually it will just only happen once because you're gonna loop the rest of the game.
Yeah.
This is the game loop. This is the round loop. So every round you're gonna check the state, right? Give the user choices based on their state, right? Generate the computer's choice based on its state, right?
Yep.
That's gonna happen every round. So that's where the dual.
Would I have to declare this variable somewhere up there, the comp choice?
Yeah.
Okay.
Yeah. You want.
And I don't have to give it a
right?
value. It's just gonna assign it when I do this. Okay.
And then here you would say like while something. I don't know what that something is,
Okay.
but I'm just gonna put the question marks there. Right, because you'll need a variable to let you know the game's over.
Yep.
Right.
I made a variable called player game and computer game. When those values I put
Or 1, then the game's
Yeah,
over.
so,
Okay.
yeah, so when it's
so
1.
while player game doesn't equal 1 and computer game doesn't equal 1.
And then it'll
Like
just
that. Yeah, and then it'll keep
restart.
doing, and as soon as one of them hits 1, that'll be false, and then
Yep.
and then it'll break
and
out.
then it'll come back and then it'll just do this.
Yeah.
Okay.
Well, this should be after this while.
So this should be up here.
Yeah.
Okay, there
Here
we
we
go.
can. Here, if you just hold on Alt on it, if you're on that line, if you're on a line of code and you hold down Alt,
You can just move it?
You just move it.
Oh, okay. Just put it right above that.
So that would go there, but that also would mean that this, right, which is part of that as well, would go up here, like that.
Okay.
So that's kind of your logic.
And then I'll just say while player game is 0 and computer games, it'll just
It'll
keep
keep
going.
moving, right?
All right, cool.
So you want that to be true for it to loop, and when it becomes false, it breaks out, then ask them to play again.
All right, thank you, Luke.
That's what you want us to count to 10?
I want you to add in by users and I already gave you that. That was from the election.
Oh, I couldn't even find it. Okay. So you want the user.
You're not gonna, so where you have 1, right?
Yeah.
That 1 is gonna be like,
Okay, so I need to ask the user to
ask the user,
Got it now?
Do you want the user to input 10 numbers?
10 numbers, yeah, they're gonna put 10 numbers and it's gonna add them all together, and at the end, it's gonna tell them the sum of all those numbers is.
So you should loop it so that it's asking them for the number and then, so, because otherwise
So you need to
10
ask them to
consecutive.
Before the loop, say, please enter 10 numbers, and then you can, in the loop, you can say like, number 1, number 2, number 3, right? And they enter them in, they hit enter, so you have to enter all 10, it's gonna add them all together. Although it's doing it while you're